Forces 4 is about power, mechanical power, not electrical power, not P equals VI, mechanical power. Now, both of these men can do a certain amount of work, but one of them will do it in a much shorter time, and that's because he is more powerful. He can do the same amount of work in a shorter time, and power is the rate at which work is done, or the rate of energy transfer. Rate means per second, how much is done every second. So power is energy transferred over time. Power is measured in watts, capital W, or kilowatts or megawatts. Here's a quick example. A motor lifts 5 kilograms, a height of 20 meters in 30 seconds. Calculate its useful power output. So how much work does it do in a second? And it is that 3.27 kilowatts. Note, I say the useful power output. The power input to the motor may be much bigger, it probably is, and that's because the motor isn't 100% efficient. You may have to use the equation efficiency is useful power out over total power in, or useful work done divided by total energy input. Useful over total is efficiency. Here's another one. A man pushes a large box across the floor with a force of 250 newtons at a steady speed of 2 meters per second. For 3 minutes, how much work does he do? Calculate his useful power. So you have a go at that, and I'll show you the answer in a couple of seconds. And there it is. Okay. Note that the power is how much work he does every second, and so that's going to be 250 times 2. Is it a coincidence that it's 500 watts? Well, no, because the power of a vehicle traveling at a constant velocity. Yeah, if a vehicle is traveling at constant velocity, then the motive force, the thrust, if you like, is equal and opposite to the frictional force, and so the work done against friction every second is force times distance over time, which is force times velocity. A very useful little equation, don't forget it. Power is force times velocity. A motorbike has a useful power output of 20 kilowatts when traveling at a steady speed of 40 meters per second. Calculate the frictional forces acting on the motorbike. 500 newtons, using the equation I just told you.